Our next speaker is Sharma, the role of organic matter in the release of iron and manganese during bank filtration.
Good afternoon. This presentation is based on the PhD research of Mr. Abdel Radi from Egypt. He is looking at the effect of organic matter on bank filtration processes. Now, to start with, you all know that increased concentration of iron and manganese is a common problem in bank filtration systems, and there are different factors affect the process. Aquifer material, redox condition, source water quality, to name it, pH, temperature, and organic matter. I think everybody knows about that. But when we talk about organic matter, which is also the focus of this presentation, organic matter is basically a cocktail, right? You have all kinds of materials there. For example, you have biodegradable compounds, which will accelerate the oxidation process, adsorption process, complexation process, precipitation process. On the other hand, we have fulvic acids, we have humic acids, we have proteins, and they all have their different roles. Some are providing even what we call the subtle electrons. Some are making complexes. So in that context, when you see increasing concentration of iron and manganese in the bank filtration well, because of this redox zonation process, right? So we have to have a better understanding of what is actually happening when you start changing the type of the organics, and what is actually happening when you are changing the temperature. So the context of this research was the bank filtration system in Egypt, in Aswan, where the river water temperature can be as high as 25 degrees, even up to 32 degrees. So we are feeding very high temperature water into the environment where even the organic composition is changing with season, and at the same time, the wastewater influence is increasing, and again, we have more agricultural runoff, so a lot of chemicals are coming into your water. So now the question is, there is increasing concentration of iron and manganese. So what is the role of this cocktail of organics coming into your water? So that was the focus of this study. So the idea was to find out first what is the impact of different organics on iron and manganese mobilization, and secondly, looking at each fraction separately, like what is the effect of humics, what is the effect of terrestrial humics, microbial humics, like that. So going into more detail with the experimental study. So this is basically summary of the results of different soil column experiments conducted at high temperature in the controlled condition at 30 degrees, and also under the anaerobic conditions using the nitrogen to flush out all the oxygen from the water, and then conducting the leaching experiments in the presence of nitrogen environment, and trying to apply different kind of water. Tap water with no organic matter or the minimum organic matter, the water with the influence of wastewater, or canal water, or the combination, and so on. And we also did control experiments in the bottle test to find out what is the role of specific contaminants. And then the data was analyzed using the fluorescent emission spectra and parafact modeling to find out what is the role of each parameters. And then some results. The first conclusion of the study was that, regardless of the type of the organic matter you put in, as long as there is, there is supply of organic matter, whether it is a piece of meat or a piece of bones, still if the bacteria can utilize them, you get an increase in concentration of iron and manganese. And in general, with the leaching test, we found that the manganese, as you see from the redox chemistry, manganese mobilization was much more higher than the iron mobilization. And then based on the parafact analysis, we try to see which is the most critical element, whether it's the terrestrial humics or it's microbial humics or protein-like substances or even the marine humics, just to get some more insight. And then we try to do some correlation between iron leaching and different parafact components. So what we see here is whether it's a terrestrial humic, microbial humic, or marine humic, for iron mobilization, there is always a good correlation. But when you look at the picture with the protein like organic compounds, you see there is a less correlation with the iron mobilization. So we can see that humics are more favoring iron mobilization than the protein-like substances. And when we look at the result for the manganese, and for manganese, you see there is no clear distinction between whether you have a humic substances or protein-like substances. So manganese is equally, amenable to mobilization in different environment. And to go much further, we try to do some bottle test like I showed you earlier, and we try to increase the concentration of humic substances starting from, let's say, 5 milligram up to 20 milligram. And in general, you see the trend, like for iron, higher the humic or higher the fulvic, higher the mobilization of iron. But when you look at the protein-like substances using the sample compound tyrosine, so what you see is at the lower concentration, there is not much mobilization. But certainly when you increase the threshold level of 10 milligram per liter, you see suddenly there is a lot of iron leaching. So that means iron leaching is very, very sensitive to the presence of protein-like substances. And with the discharge of a lot of wastewater and the industrial wastewater, so with the nitrogen compounds, it's likely that iron mobilization will be much more in the future. Yeah, I'll stop the presentation here because already there is a buzzer, but if you have some questions, I'll be happy to answer.
Thank you. Very, very interesting talk. Do you have any questions?
Yes, please.
Yes, thank you, Sharma. You were very rapidly going through the story. This is very well done. I had a question if the iron and manganese already leads to severe problems, and if you, based on your results and insights there, are already thinking of possible mitigation of those problems.
Well, what is the situation in Aswan, if I may tell you more, is the wells are rather old, and then they were not designed as a bank filtration wells. They were designed as wells next to the river Nile. And then because of that, then when they started using those wells and they see with time a lot of iron and manganese coming out, and many of these wells are being shut down. Whenever you see, they have many wells, so whenever you see increase in concentration of iron and manganese, you shut down that well and you go to one which is farther. This is how they are operating now, right? And then the idea is now to see why this iron is really increasing. Is because of the sediments or because of the organics or because of the temperature or a combination. So that's why, this research is in process.
Fact-finding first.
Yes.
Thank you very much. Appreciate it. That was a great talk.
Thank you.